Hello, hello. Jim. Um, wait. I'm I'm not at home. I'm in a camping. I lost my stuff. Oh my God. What the fuck? Uh, So yeah. Hope you are doing well. Um, I didn't sunburn yet because I'm not going outside. Mon Dieu. Um, yeah, that's nice. Some people are already there. Let's wait. ETT. I will put my camera off like this at a moment because I'm in upspot. Upspots. Yeah. Yeah, I'm in a camping, like in the south of France. But yeah. Um, I will have fun from tomorrow, maybe. Uh, all right. Just let me put a recap. ETT, are you there?
Hi, Solan. GM, everyone.
Perfect. Let's go. Ugh, just put the message. Ah, the link, of course. Of course. The link. Stuck. All good. All right. So normally you put your homework yesterday, I guess. I guess. When I was checking, there is a lot of people who's done it. Let me check. Oh, wow. 53 people complete the assignment. Congrats. That's pretty cool. Wow. All right. So the LISC team, ambassador team, is actually reviewed this one. Yeah. Um, to make you feedback about it, and yeah, I think we can start. Sorry, I'm talking too much. We are 30 actually, but people will come and and yeah, just follow. All right. So as I mentioned, I will just cut off my camera because I'm in a share like HubSpot, so it's gonna be better. And I hope you're gonna have the recording session tonight, but it's like really hope because the connection, I don't know if it's gonna crash or not. All right, let's go today.
Okay, thanks again, Celine. Hi, everyone. It's great to be here again. I'm just going to share my screen, but before I do that, from the first earlier class, we looked at looking for the share button. Sorry, share. Okay. Uh, yes. Please confirm you can see my screen now. Okay, awesome. Thank you. All right, so from the previous class, we did talk about the syntax of Solidity. We looked at some data types, both the value types and the reference type. We didn't really do much into deploying or really setting up a smart contract. I just wanted to make sure everyone got how the smart contract works behind the hood. So today we're actually going to dive into deploying the smart contract itself. And then, like I said, I'd like to take questions, maybe 5 minutes, 3 minutes. Any questions from the previous class, please just feel free to unmute and ask your question. Oh, we are all good to go.
I do have a question, but it's not about the assignment.
Okay, so go ahead.
Okay. I was reviewing the data types. that are available in Solidity. And I was wondering, how do we, I noticed we didn't have like anything to do with like decimal or float types. Are those types available in Solidity? If yes, what are like the types? How do we specify them?
Okay, so if I get it correctly, you mentioned that we didn't talk about decimals, decimal like floating point numbers, right?
Yes, sir.
Okay, yeah. Okay. So Solidity does not support floating point numbers. The reason being that it's on chain, right? It's a permissionless system. So what we do instead is we'll take a look at it later today anyway. So what we do instead is we kind of like multiply that value. We format it basically. So if I needed like 18 zeros, which most tokens use, I'll need to format that to multiply it by the exponential of 18, that's 10 raised to power 18, right? So that's one way to deal with decimals. So if somebody sends like, for instance, 0.38, behind the scene is going to be like 0.3 times 10 raised to power 18. So you could actually, it's not like a decimal, but it's a big integer. But we'll take a look at it today. That's basically we format it basically. We do not Solidity does not support floating point numbers, unfortunately. And also remember, most times or almost all the time, you see developers using unsigned integer. That's also because Solidity you need to deal with positive numbers, not negative numbers. I hope that answered your question. Sorry.
Yes, it
Uh,
does.
okay, yes. So instead of like doing like for instance, let's use real case scenario. So a token like LSK has 18 decimals, meaning that, of course, like I said, it's formatted to 10 raised to power 18. So if you were sending someone like, for instance, zero point 0.5 or 0 point anything LSK, behind the scene is formatted to 0 point that amount, basically multiplied by 10 raised to power 18. Now it's different for some other tokens, like for instance, USDC, I think is 8 decimals, so it's going to be 10 raised to power 8. And also some other tokens might have different reasons for choosing any amount. So most times it depends on the total supply of the token, but that's tokenomics. Let's talk tech today. Yeah, so okay, so I think we can kickstart. At any point, please feel free to, I need to reduce this. Okay, so at any point, feel free to maybe unmute and ask your question just in case I'm not, because definitely I'm not seeing my chats right now. Okay, so again, my name is Etete Talk. I'm a software engineer. I'm also a 3 dev. These are my handles. It's great to be here. All right. Okay, so today's agenda. We'll be taking a look at Foundry. Foundry is a development tool is actually a tool, development tool for deploying, writing, building, testing, and deploying smart contracts. Remix is another one. But then if you're working in like a real world scenario, I mean, you could use Remix for that, of course. But if you're like working in like a real world scenario, like a major Web3 project, you need to do a lot of testing. You need to try out a lot of scenarios, simulate a lot of scenarios to check for bugs and all of that. So there are some tools that allow for that. Foundry is one of them. There is also Hard Hats. There are many of them, but Foundry is the latest because Foundry basically allows us to do everything in native Solidity. We'll take a look at Foundry. But in a continuation to the last week's topic, we're also going to look at the concept of inheritance. Remember, we said Solidity is statically typed and also object-oriented. So that means it supports inheritance, which is, of course, one of the four pillars of, I think, object-oriented programming. There's also polymorphism and the rest, but it also supports inheritance. This is very important because the concept of inheritance allows us to write more secured and upgradable smart contracts, which we'll see in a minute. So the reason is that, remember, anything you deploy on the blockchain is immutable. So what if you wanted to upgrade your software? You already have users using your smart contract or using your application, and then over time, maybe you want to like upgrade the software or the version of your application. You can't go and edit your already deployed smart contract, right? So one way to do that is to write a smart contract in using an upgradable standard. There are many of them. So, but behind the scene, inheritance basically allows us to do that. We're also going to look at the concept of libraries, just like um, coming from other programming languages. Of course, we are familiar with libraries. Libraries are just a class of functions that basically allows us to do some utility computation. So now the blockchain is very vital and necessary, because sometimes when you are doing heavy computations directly inside your smart contract, it's going to cost your users more gas. But if you have like a deployed library, you can always reuse that set of functions without necessarily deploying a new smart contract. So I will take a look at that. And also events. Event is a way of like indexing what's happening on your smart contract. So you can trigger certain events. Say if you have like, for instance, an ERC20 token smart contract or any token smart contract, you probably want to trigger certain events. For instance, when somebody transfers funds, somebody bonds funds, if the bondable is allowed, right? So also take a look at that. And then we'd also look at errors and error handling. From the last class, we talked about conditional statements in Solidity. So today we're going to take a look at that and how we can use that to check for errors in our smart contract. Then, yeah, that's our agenda for today. Seeing some pop-up, do we have chats? Can chat between Foundry and Hata. So Sonia, there's both of them do the same thing. The difference is that both of them do the same thing in that they allow you to write smart contracts, test your smart contract, deploy your smart contract, and also interact with your smart contract. But the difference is that with hard hats, you write a smart contract in Solidity, but you use JavaScript to write your tests and also maybe to deploy and interact with your smart contract, or maybe TypeScript also. But when you're using Foundry, everything is done in native Solidity. This means that you're using Solidity to write your code, your source code. You're using Solidity to test your source code, and then you can use the Foundry command line to basically deploy your smart contract and interact with your smart contract. So, okay, I think, yeah, somebody answered that. Thank you very much. All right, Sonia. So we'll go ahead. Move. All right, Foundry. Okay, so this is like a prerequisite. Basically, I have this deployed in my system. So, but if you don't, you need to have Node.js already installed. You need to have npm installed. You need to have JIT, and then all you need is to run this Foundry command from your CLI, your command line. That's your terminal, and it will basically install Foundry for you. If you're using like your Windows system, this command might be a bit difficult from your PowerShell terminal. So what you can do is you can install Git Bash. Basically, Git Bash comes with WSL, and then you can use the Git Bash terminal, and then this would work. And then once you
Yes, just could you put the command on the chat by any chance?
um, okay, sure. Yeah. So I think I'll just share this. There is a book online, Foundry.share. I think I need to confirm that, guys, so I don't give out. Let me just confirm this. Sorry. So Foundry, this should give us the book. So it's all the commands are there, including everything we'll be needing for later, just to be sure. Uh, this is not this. That's this is, uh, just sorry guys. Let me get. I need to confirm this link. I don't know why this. Okay. So while I get that, I understand you can use Kusono. It has terminal inside. Okay, so it's get foundry.shell, not foundry. Yeah, needed to confirm that. Yeah, get foundry. Yeah, thank you, Hashi. So that's the link, guys. Get foundry.shell. In short, I think I should basically go there. We could do a bit. I was going to come to Foundry at the end of the class so that we can actually try our hands on it, which we will still do, but this is going to take a while. Okay, yeah, so this is the command you need. So it's as easy as this. You run this command in your, let me still put this in the chat. You run this in your CLI, your terminal rather, sorry. And then, of course, after running that, all the next thing you have to do is just run Foundry up, and then Foundry is installed in your device. And to get the latest nightly release. But normally just Foundry up is enough to get you started. We'll take a look at this towards the end of the class. But for now, please, you can go ahead and run this and have it running on your device. So I did say if you have like a Windows system, you need to install Git Bash. I'm putting it in the chat. I'm not going to look for the link, but it should just install Git Bash and then you should be good to go to be able to run this on the Git Bash terminal. Yeah. Okay, so the source directory, yeah, so when you install, anyway, we'll take a look at it at the end, but normally this Foundry comes with like certain folders. So the source folder is where you have your source code, that's your smart contract, your Solidity smart contract. You can have one or multiple source code. The test folder holds test files. So Foundry basically follows it has like Next.js, right? So Next.js is all about convention, not configuration. So you have to follow a certain convention, not to configure your things, just like React and Next.js. So yeah, something like that. So Foundry is about convention, it's not about configuration. So this means that you just have to follow certain conventions so that Foundry can know where to find certain files, where to find or where to interact with certain files when you call them from your command line, which you will do later on. So you also have a library folder where basically like node models, if you're running like a Node.js application, right? So you have node models. So all of that lives in the lib folder in your Foundry application. And then when you compile it, your compiled artifacts, you can find them in the out folder. We'll take a look at that also later on. Guys, okay. So moving forward, Foundry, like I said, is a powerful tool for developers to build and deploy apps. There are many, there are three main commands that we would most likely use. There are more, but most times there are three. I think there are actually four. Actually, there's only Chisel that is not here. So Forge does like the heavy duty. So you use Forge to initialize a new Foundry project. You probably use Forge for most of the heavy duty, like building, which is Forge build will compile your smart contract. and then you can run tests using Forge tests. You can deploy your smart contract using Forge crates. So basically, Forge allows you to do the building side. When you finish writing your smart contract, to compile it, to test it, to deploy it, all of that, you'll use the Forge command. And then the cast command basically allows you to interact with the deployed smart contract. So using certain commands, CLI commands, which you don't really need to memorize all of them. Personally, I don't know all of them. There are so much, but you just need to understand how to navigate for what you're looking for, which also we'll take a look at it later on today. So Anvil, on the other side, helps you spin up a local blockchain node on your local device. So instead of looking for testnet tokens to actually deploy your smart contract and test it, you can do just like Remix gives us the interface with the faucets and that all of that in an environment to test. So you have all of that environment in the Foundry Anvil, where it just spins up a local node, gives us some set of addresses and some set of wallets, private keys to sign on those addresses. I'm seeing some chats. Why we should use Foundry, there's another framework, Truffle, easier to set up. Yes, yes. So truffle is easier to set up. There is no saying there's how do I put this? It's all about choices. So there is no tool that is better than the other. It's all about how well you can use it. But I think Foundry Foundry is very, very much straightforward. It does not complicated, right? You don't have like everything is in the environment, which you can do that using a familiar programming language like Solidity that you know. So for some other person, maybe Truffle is a lot easier. I mean, there is no right or wrong answer. All development tools are cool as long as you yourself, the developer, your logic is secured, and then yeah, of course, or any development so you're familiar with. Yeah. Okay, so moving forward, all right, inheritance. All right. So earlier I was talking about inheritance. So I was saying just Solidity supports inheritance, just like every other programming language, right? So we're talking about object-oriented programming, right? So Solidity in this case, I said earlier that Solidity supports inheritance, which basically allows one smart contract to inherit from another smart contract. So what this means behind the hood is that I'm going to use some illustrations. So you say you have a contract A, and contract A has maybe some state variables, and then maybe some functions. Let's say, for instance, you have a function, or let's say it's a simple ERC20, and then you have your state variables. That's the name of the token, the symbol, the total supply. Those are your state variables. The balance of the mapping, those are state variables. And then you now have a function like to mint, and then you have a function like to transfer, right? So you can mint and transfer on contract A. And then that's going on very well. And then later on, you decided to, okay, maybe we should have allowed people to bond, to be able to bond, right? So we should have allowed people to be able to bond. So now what do you do in that case? You cannot go and change contract A, right? Because contract A is already immutable. It's on the blockchain. But what you can do is not the very best, but what you can do, lot technically possible, is that you can have a new smart contract that inherits from contract A. So inheriting from contract A means that it's going to have, even though you are not going to define all of this in the new smart contract, in the contract B smart contract, it's going to have all the state variables of contract A and all the functions of contract A, provided that those functions were the visibility is not private, right? So remember, if the visibility is private, it means that it's only going to work within that smart contract. So if you inherit it, it's not going to work. But if the visibility is internal, external, public, once you inherit from another smart contract, you can be able to access the state variables and the functions in that smart contract. If you don't want another smart contract to inherit some of your state variables or functions, you just have to mark the visibility as primary, right? So when contract B inherits from contract A, now contract B, the compiler already knows that, okay, contract B is inheriting the bytecodes of contract A. So now you don't even need to redefine those bytecodes. You can just have your new contract B with maybe a single function, say born, and then when you deploy that, it's going to have what you're going to deploy is going to be the bytecode of contract A and also your bytecodes concatenated together kind of into a single bytecode, because you'll be able to access your new function will have all the state variables, and then it will also have all the functions both in contract A and contract B. So Solidity allows one contract to be able to inherit from another contract. The implication of this in real world is that, for instance, you see there are some standardized smart contracts. Standardized here means that they have been audited and they have been graded safe for users. You have libraries like OpenZeppelin providing a lot of these standardized contracts. So when you inherit any contract from OpenZeppelin, say an ERC20 or any other of their contract standards, what it simply means is that you are inheriting the bytecode of that smart contract, which of course is deployed on-chain. So you can actually have those functions. You can access those state variables and those functions in your smart contract, but in the context of your smart contract, that's in the memory slot of your smart contract. There is a way you can do that the other way around with delegate call, but that's something for maybe another class. But today, we are going to look at how inheritance works. So, of course, there are certain things also. So a contract, certain functions, um, let's say that has the mint function, and then you want to have your own mint function and function B that has the same name as, name collision also. It has the same name as that in function A, but then you want the one in contract B to maybe tweak the logic a bit, tweak the logic a little. What you can do is the function that you want people to be able to tweak the logic, that's the parent contract. In the parent contract, you have to also add a modifier to tell this compiler that if anybody is inheriting this smart contract, they can use the name of this function and then they can modify it in their own context, but they have to declare that function as virtual. And then in the contract B that you are inheriting maybe the parent contract into, and you want to probably modify the logic of a particular function, say the same mint function, you have to also declare and tell the compiler using the override keyword that, okay, this function is actually in function A, but I'm going to override it in function B and I'm going to tweak it a little. So the compiler knows all of this. So in contract A, you have to declare functions you want to maybe make people, you want to make available for people to modify later. You have to declare them as virtual, right? And then in the inheriting contract, and which wants to modify these functions, you have to declare or mark those functions as overrides, so the compiler knows all of this. So, of course, you can inherit multiple. A particular smart contract can inherit multiple smart contracts, but it falls in a particular order, right? So let's say contract, we now have like a contract C. Somebody saying something. I'm seeing chat installed. It works. Is there need for WSL to be installed for Windows users? For Windows users, yes, you might need to install WSL to be able to do that. Yeah, because Rust originally is, I'm sorry, I say Rust. Foundry originally is written in Rust. And of course, the PowerShell, the Windows PowerShell will not be able to execute some of this on their terminal. So you need the WSL to allow you to access the proper Linux terminal. Okay. So I was saying that you can inherit multiple smart contracts, but it depends on the order. So if there's a new smart contract, say contract C, that wants to inherit A and B, contract A and B, right? So it depends on the order. Now you inherit a contract using the is keyword. So and then you specify the contract's name. So let's say contract C wants to inherit A and B. So if when you inherit it in this format, like contract C is A, comma B, what it means is that A would always come first. So if you do something like super dot, a function name, super basically is going to call one step layer on top. So depending on the order, if it is B before A, it's going to call the B contract before the A contract if they have the same function name. Or if you are referring to super, in which case you are referring to a parent contract. So it's going to call based on the hierarchy of who came first. We'll take a look at all of this also in code. Please, at any point you want to ask a question, I'm not seeing your hands, so feel free to unmute and ask your question. Okay, no questions. All right. So that's that for inheritance. I think I should be explaining this in code. Let's see. So I have this. This was supposed to be for illustration. So, but this is basically what Foundry looks like. This is a new project, actually. I just initialized this a minute ago. I'm going to increase the screen so that we can see. Okay, so this is what the Foundry project looks like. We have the lib that holds the Forge standard library that gives us access to a set of when we're doing testing, we'll take a look at that. But it gives us access to a set of let's call them cheat codes that basically allows us to simulate different or any we can simulate anything on the on-chain, on the blockchain. We can simulate any address, any smart contract, anything just for testing purposes. We have the script that holds scripts. Basically, you can also write scripts in Solidity, but and then we have the source. So the source has this counter. So it's a default smart contract that came with once you run Foundry up and then you do Forge init, like to initialize Forge initialize. I already initialized this, so I won't be. Well, this would spin up exactly this Forge init once you have Foundry installed. I was talking about inheritance, so I'm just going to take. So let me expand this. Let's see. So I'm going to take all of this out except the Pragma version. So I was saying we have a contract A. So this is contract A. Contract A would have, I don't know, okay. Contract A will have, let's say, a state variable, right? Let's say string public, we can call this name, and then we can have name and city, right? City would be a string, it's also public, and we can say city, right? And then we can have a function, and we say set name. Okay, so let's be able to set name. We should also have the same to be able to set city. So let's say function set city. So we have public. This is pure. No, it's not pure because it's going to change the state of the blockchain. Okay, so we have this function A, right? And then I'm saying that this function, this contract is going to set the name, is going to set the city, and then I think that's pretty much it. Then we can have, to inherit this, we can have a contract, say contract B, and then contract B using the is keyword to say contract B is A, right? So what this means is that even though we do not have anything in contract B, already is going to inherit all of these functions that are public, that are not as long as the visibility is not private, right? It's going to inherit that function. And then we can say we're not going to have any state variables here, but we can say something like let's say function gets name, and then it's going to return name, and then maybe the same. No, this is okay. It should be the same for city. So what we can do, this is cool. We can do this in Foundry. I will be going back and forth. I'm going to take this to Remix. The reason why is I want us to have Foundry at the end of the class. So I'm going to take this to Remix. That might take a while. So I don't want us to see how this works. We'll go to Foundry to do this also, but I'll be working from my terminal. Okay, Sunday, Moses, your hand is up. Please go ahead.
Okay, good afternoon, good evening. So my question is, what if we have a constructor on the contract that we inherited? How do we still use it? And then the next contract that we're going to use, the inherited contract, we equally have a constructor. How do we go about that?
Okay, cool, amazing. So to see that, let's add a constructor here. So let's have a constructor here. Constructor initializes our state variable, which is fine. So if we have a constructor here, in the inheriting contract, we are also going to specify in the constructor, because we're going to pass constructor also to it. So here what we can do is we can also have a constructor, because we are inheriting from a contract that's I hate this AI for this. But even if we didn't pass that, right? Even if we didn't pass, I saw the AI do that. So what I'm saying is that as long as we have this constructor, we are going to also initialize a constructor any variable or parameters in our constructor. But since we know that our constructor here, our parent contract rather, has a constructor that is expecting some input, we can also initialize that in our constructor, right? So I can do what's the name of this? This is contract A. So I can do something like, I can do this, I can do A, and then I can just pass in some names, say John, and then I can pass in city, I'm in Abuja, so I'm going to put that, right? So basically, this is how we initialize that. So there are two ways. I could do this, or I could just also do the same thing by basically accepting input when I want to deploy. So remember, the concept of constructors is that they are the first things that run, or they are the first line of code that run when in any other programming language. If you have a constructor, that is the first line of code that runs, right? So in Solidity, when you deploy a smart contract, if you have a constructor, it basically means that once this smart contract deploys, this is the first action that is going to happen, right? So somebody saying something? Please go ahead.
I don't know. Misty. Nothing to say?
Okay.
I don't think so. I will mute.
Okay. All right, so once, forgotten where I was, but basically, once you have a constructor in a parent contract, you have to also initialize. You can either initialize the constructor in the child contract this way, or I can basically do the same thing here by taking this. If I want to pass this at deploy time, so I can do this also, and then I can do name here, and then I can do city, city, right? City. So basically, is the same thing, right? So this would be supplied when I want to deploy. So I could always change this. But if I don't want to go through that route, I can basically do the previous one that basically tells the compiler at compile time that I'm going to initialize my smart contract, which is contract B now. Remember, it's going to inherit all of this up to this point. It's going to inherit all of this from contract A. So I can initialize it at compile time, so the compiler knows beforehand, or I can do the other way around, which is something like this, which basically is I'm going to supply this when I want to deploy it. So either one works, just depending on your logic or what you want to do. So I was going to test this out. Let's see. I want to take this to remix for now. We'll still come back to, I'm going to have a new file. I'm going to call this, I don't know, anything, find.solar. Okay. So I'm going to paste this here. I think I need to expand this a bit. Okay, so we have basically the same thing. We have a constructor, and then what's going on? Let's see. What is the error? Functions without implementation cannot have modifier. So function without implementation. Okay. The compiler is complaining about something. Let's see if we can. Right, then we can person. Function get name, God functions. So, oh, okay, I see what's happening here. We didn't even forgot to add this parenthesis at the end to tell the compiler that it's a constructor. That's what we failed to do there. But either way works. So anyway, here we have only the get name function. We have the set name, which is inheriting from A. So if we should deploy this, this is, I want to deploy contract B, is contract B. So if we should deploy this, it's still going to ask for the name and the city, which would be initialized here at this point. So the name would be John, and then the city would be Boulder. And then we can deploy this, and we have the smart contracting. But now you see that our contract B now has the set city, the set name, it has everything that has that contract A has. Remember, anything that contract A has that was declared as public, right? That was declared as, or rather that was not declared as private, because even if we declared anything as internal, we can always inherit it. But if we should change this set city to private, and then we would not be able, it will throw an error because we'll not be, okay, we can get name, but we cannot get city. All right. So let's see. We should be able to get the name without this.
Are you
All right,
painting?
somebody,
Fine, fine.
please go ahead. I thought someone was asking something. Let me check the chat. Import function, function is, we can assign values without using setup functions. Osadhid, I don't understand what you mean, but if you want to assign a value, you are going to change the state of the blockchain. So you definitely need the function to do that. Yeah. Okay. So yeah, this was, I don't remember where I was at, sorry. So, but basically this is what inheritance looks like. So contract B is inheriting all the functions and state variables of contract A. And then we can actually do things like here we get empty Abuja. Okay, yeah, because we initialize that in the constructor. So we should set the city name to, let's say, New York. and then our city should change to New York. So basically, we are able to access or use the functions even though we did not define them yet, right? So that is inheritance. Let's continue. Any question? Okay, the override keyword thing, right? So this is what it means. So I have a get name here, I have a segment. So let's change it back to public. So I'm going to have a virtual function called set city, and then it's only going to return the city. We need some logic here. Let's see. So I'm going to do function to override this, the same thing. So this will be set city, and my set city is only going to take the string in memory.
Right? You can rest assured of that.
Okay, cool. So this will be public, and then I'm going to override. Do I need to return anything here? I'm just going to return true. That's a bool. And then I'm going to return true without doing anything, right? So I have an unused variable defaults because it's a string, and then I'm returning a bool, right? I understand this. So we need a logic here. Still the same thing. We can set the city, and then I don't know. So, but basically the override is going to override whatsoever logic we have here. I can't think of one now. It's basically the same thing it can be. But let's move forward. We're going to come back to all of this in Foundry later on. All right. Okay. So this is a simple illustration of the inheritance I was talking about. So we have a base contract, and then we have two child contracts inheriting from the base contract, right? So one overrides the base contract and the other does not override the base contract. So child A overrides the function greets, while child B only inherits without overriding, right? So in the right here, we have this illustration, little illustration to show for it. Okay, so yeah, that's for inheritance and solidity. This is very essential because think of it as where you can really utilize this is when you're writing like complex logic smart contracts, and then you're writing something like an upgradable smart contract where you basically want to separate your logic from your storage. What this means is that your storage, your state variables, all of this could be a smart contract on its own. And then you can now have smart contracts that inherits from your storage, which is inheriting your state variables. So if you needed to, like, for instance, change logic, maybe upgrade from version 1 to version 2, you will still retain your memory, your storage, which is important, but you can always change your logic, which is the smart contract that actually does functionalities for you, right? So you could change your logic and maintain your storage. That way you have an upgradable smart contract where your storage is always constant, but you can always change your logic depending on what you need to upgrade to, right? So that's why inheritance is very important in Solidity. Okay, I'm going to drink some water. Okay, back. Any question? 14 in the chat. Step by step. Okay. Inheritance doesn't have to be the same. Yes, Sonia. Inheritance doesn't have to be in the same file. Basically, you can import different files and inherit from them here. All right. So I think the chat is quite chatty. I'm gonna move ahead now. Okay. Libraries. All right. So libraries in Solidity, like I said, just like coming from other programming languages that we come from, we know that a library basically is like a utility thing, where we define certain functions that we would always reuse, and then we don't want to define it every time. So we could define it once in a library, and then we can always reuse that library. So in Solidity also, this is very, very important because it helps us to it helps our code base not to have redundant functions. That's first and foremost, right? It helps us organize the code. And then of course it takes away the heavy computing from our smart contract, because smart contracts have a memory size. So that means that if you write any smart contract that is bigger than 24 kilobytes, it's not going to compile. That's kind of like how it is. So whatever smart contract you're writing has to be under 24 kilobytes. So imagine like having smart contracts that do a lot of computations, right? So this is going to be, first and foremost, it's not going to be design friendly. It's going to be expensive on your users, because every time they call a function from your smart contract, the smart contract has probably a lot of complex algorithms or complex computations, and every computation, of course, translates to an opcode, which means that there's going to be an accumulation of gas fee to pay for all of that. So libraries, on the other hand, basically helps us by libraries, by the way, are stateless. They are stateless here means that they do not hold any storage. They do not have state variables, so they cannot hold any storage. They also cannot hold ether, so you can't send any form of it to a library, right? And then we declare a library using the library keyword, and then we can define our set of functions. Libraries do not inherit from other libraries. That's something to take note of. Libraries do not inherit from other libraries. They basically exist as utility to help. You could have mathematical computations, you could have string computations, whatever computations you can do that would make that would take out the heavy computation or heavy computing away from your smart contract. And then of course, libraries can be deployed on the blockchain, meaning that you can have a set of functions, of reusable functions, and then you can deploy that on chain, and then any application you are building that you needed to use that library, you can just basically plug into your on-chain library and of course use whatever function that you want to use there. So libraries are super cool. They help reduce, like I said, they help make our code base more organized. They reduce the heavy computing from our smart contracts, making it more cost efficient. So it allows for users to use our smart contract without paying more gas fees. So the essence of actually being an efficient smart contract dev is to be able to write smart contracts that are both secured and cost efficient. So hopefully we'll do that before the end of today. So let's see. Yeah, so libraries are reusable. They are efficient. Functions in libraries can either be internal or public, right? So yeah, and of course we use when using a library in a smart contract, it's quite different because Solidity is statically typed. This means that even when you're declaring a library in your smart contract, you must tell the compiler the type. So what this means is that let's say you have a library that does maybe string concatenation or maybe does simple arithmetics. When you are importing that in your smart contract, you have to tell the compiler that, okay, I'm importing this library and I'm going to use it for either unsigned integers or for strings or whatsoever data type that you want to use it for. But you must always tell the compiler what type you want to use the library for. So we'll also take a look at that, or we can just probably take a look at that right now. So I'm going to, okay, so let's see, I'm going to take this out. I should probably take all of this out. maybe not. Okay. Anyway, you can always define it here. So let's define a simple library using the library keyword. And this library, let's see, this library is going to take the name of the city, the name and the city, and is going to concatenate it, right? So let's give it a name. What's the name we can use? Let's say library test. I don't know. I'm terrible at names. All right, so we can have a function, say join, something like that, and it's going to take string, uh, going to take two strings, string one and string two, and it's going to concatenate both strings. So it can either be internal or public. So it's going to be public. It's going to be pure because we are not going to change the state of the blockchain. And what do we want to return? Let's return a new string, string, which is going to be the concatenated string. So here we can return, do something here. The reason why the AI is popping up. So the reason why we're having this here, ABI.encode pack, is because we'll talk about this when we're talking about vulnerabilities. So, but why I'm doing this is because if I want to join both strings, right? So it's not gonna allow. Remember, strings and under the hood are just bytes. Arrays of characters, and then our Solidity compiler is not going to be able to. We're defining it as strings. So already we're taking off 256 bytes of that storage. So we are not going to be able to add anything to that string anymore because the string alone already takes away 256 bytes. But what we can do is that we can encode it. That means that we can return it to bytes, and then we can encode both of them, and then we can have that byte version of it added together and return the string versions. It's just what's happening behind the hood here. But we're going to look at this when we're talking about vulnerabilities in smart contracts, and that will be in our next class. But this basically is going to allow me to add strings. If I was going to do like a simple arithmetic, I wouldn't need to do this. I can easily do function, say add, and then I can take an unsigned integer this time, 256. It's easy to add a comma b. That's two of them. And then I can just literally do the same thing here. But sorry guys, I'm a lazy typer. But instead of to return a string of it, I'm going to return a signed integer here. Integer. And here I can return a plus b. And this will work perfectly, right? So I need to my closing rust. Okay. All right, and this should work perfectly, right? So, but in the case of strings, handling strings in Solidity is a bit tricky because also like when you're having conditionals, you don't have to make your string very long because it's also going to cause gas. Like I said, strings are just arrays of characters, so it's always going to look. We'll take a look at that. I don't want to deviate. It's always going to look through that to actually get. So it's going to cause more gas. So this is our library. So to use this library, I don't want to use the string, the join. So I want to join in our contract B. I want to join both. This is where the state variable is. So I need here. So I'm going to use, say, what is the name of our library? Tests. I'm going to use tests. for string. So I'm going to use the library, but the type I want to use it for is for string, right? So I want to use test for string. If I want to use maybe the addition part, I could also do something like this. I also do something like using tests for unsigned ints, and then I can basically use this function add because it's expecting unsigned integer computations, but contract A is expecting a string. So I have to tell the compiler that I'm using this library for a string, but I might decide to use this library for, let's say I wanted to add this here, the addition part, I could do something like function, let's say, and then it's just going to take this guy. I need to declare anyway. It's public already. I need to declare this as public. So anytime you do not give a visibility to your function or your state variable, they default to 256. They default to public behind the hood. I just needed to specify that. So I want to use this function add in contract B and use function join from the library in contract A. Let's do it one at a time. So I'm going to have a function, say function concat, and it's going to take string this time. Lazy typer. Going to take both of this. And then because we are reading from the blockchain, I want to return a string. Okay. So what we can do is we're going to take the name and then we're going to join it. Remember, we have already told our compiler that we're using the library test for strings. So here I can just call this join function by saying my name, and then I'm going to concat it to B, right? So I'm going to concat the name. So I can say name, I'll say name dot join, and then I want to join city to it. All right, so here I'm using the library and then I'm saying name dot join. So I can actually use the function join in my contract A this way. There are multiple ways to do it, but this is one way to do it. So name, and then I'm joining the city to it. And for here, we have a function mat. We have the add, so we can also do the same here. So we can take these two and then we can make this public, probably pure because we are not reading from the blockchain. And then we want to return unsigned integer. And then we can do the same thing. The function name is add, so we can do a dot add, and then we want to add b. That should work pretty well. So here we are using our library. So instead of having our contract, this is our contract, remember? So instead of having our contract actually do the computation of adding it, we can take this public this issue expected, but got, okay, we did not specify a return type. Public, this will be pure. And then we want to return a signed integer. I think that should take care of that. Public was the issue now. Expected curly braces, but got, oh, we're having two public, sorry. Sounds so problem solved. We still have one more problem. Where is the problem coming from? String. Oh, okay. So we did not return the string. So we can say string uh, string memory, let's say full name or something. And then we can return the full name so the compiler stops complaining. String in memory. So this should be a pure function. Yeah. All right. So I think we have satisfied the compiler for now. Assign is 256. Oh, we are not returning anything here. That's why it's complaining. So sorry. Remix is cool because it's always going to let you know what you're missing. But if you do this, probably with Foundry, you might only get these errors when you're compiling. So we can return C here easily. So this also one cool thing about Remix, it gives you the IDE, so you can actually do your stuff with it. I think, yeah, so everything, we have satisfied the compiler, everything. Okay, so we're talking about libraries. So we have our library for the string, and then we have another library for math. So let's see how that plays out. I'm going to take this out. I'm going to deploy contract B because remember contract B inherits everything from A. So we should have everything, excuse me. So we should have everything in B. So I want to deploy contract B, which is fine. All right, so I'm just going to pass in another name, say Luke, city, Paris, Paris. So we could actually concatenate two strings and we can add basically A and B. So we could do maybe A, not A, assign integers. Ball, and it should have name ball, right? So this is our library in action in our smart contract. But now we have taken away the heavy lifting from the smart contract itself, and then we have a library actually do that for us. And yeah, so normally I saw someone talking about having it in another file. So let's say we had this library in another file. Let's say let's have a new file. Let's call this HH.so. I'm terrible at naming files, sorry guys. So we're gonna have this file here. Okay. We still have to declare to tell our compiler about our license identifier and the compiler version we want to use. So it's gonna be anything greater than 0.8 point, maybe 20. So yeah, I have that. And then I can import this in my main file. I'll take this away. So these are smart contracts. So now we don't have the library. So we can import our library this way. We can import tests from the name of the file, right? So what's the name of the file? What did I name it? HHH, I think. Double H, so to have HH also, and that should solve our problem. Basically, Open Zeppelin offers sets of smart contracts. If you come here, you have so many smart contracts from account abstraction to tokens to governance, smart contracts, and all of that. So, of course, this is how you install it if you are using Hard Hat. Somebody mentioned Hard Hat before, which is native. You interact with smart contracts using JavaScript. So you can install it in your application, which could be either hard or Foundry, using this command, the npm command. So you could install all of these contracts, and then you could basically pick out the ones you want. I'm going to show us that when we're doing Foundry in just a minute. But with Foundry, you can also use this command, the forge command, and then it will basically install the same set of smart contracts and do your remappings. So the remappings basically tell Foundry where to look for your smart, the libraries that you've just installed, right? And then this is an example usage. This is an ERC20 contract from OpenZeppelin. So after running this command, either the npm install or the forge install, you can import it this way. This is an import statement, and what they're importing here is an NFT ERC721. So that's basically an NFT smart contract. So and then you see they're using the is keyword. So this is the name of your own smart contract in this example, and then this is the contract they're importing from. Now the reason why it's this way is because you do not have this file in your project, right? You do not have the source code that has this file. This file is actually hosted in a repository, and then you download that into your contract using either npm or the forge install command, and then you can then import what you want into your smart contract. Already you've installed the contract itself, the libraries, so you can import it this way, and then same thing using the name of your smart contract and the is keyword. You can use that. This is actually a contract. Now it's the same thing for a library, right? The only difference is that when after importing a library, just before the constructor, you need to declare here, you need to declare the type of what you want to use the library for, right? So OpenZeppelin has a lot of them. I think there's stuff about access control. This is actually a contract. Let's see. Let me see if I get like the library kind of thing, interfaces, access control. Uh, yeah, let's just see. It might take a while to search, but basically it's the same thing. The only difference is that this is hosted on a repository like GitHub, and then this is another smart contract here. So you see they're importing it, and then using the is keyword to tell your own smart contract compiler that, okay, I'm inheriting from this smart contract, the enabled or so smart contract. But what I need from this smart contract is the enable, right? So maybe there are other functions or other contracts in this particular source file, but what you need or what this person needs is just the enable, right? So using is, I declare the enable here. So if it was like a library, like I said, after importing it, you need to now tell the compiler what type you want to use the library for. If you're using it for a string operation or for an integer operation, basically. Julia, I hope did I answer your question?
This is great. Thank you so much. Yes, for sure. Yeah. Well, the chain link data, you also do the same, like using the import function, like.
Chainlink, yeah. Of course, Chainlink is also hosted in a repository, so it is basically the same thing. You import it, and then, of course, you can use what you want. You can also, this could be more, say, for instance, this enabled or so. So this is where this lies on their GitHub, basically. So if this enabled or so like has maybe multiple smart contracts with different names, say enable is just one of the names, and you needed more of it, you could just add a comma and then pick out what you want. So yeah. I hope I didn't confuse you more, but great. Awesome. Okay, you're giving a thumbs up. I think she's cool. Okay, great. So moving forward, here we are. I think we're done with libraries. Okay, awesome, great. Any question from any other person before we proceed? Any other person want to have asked a question so far?
Yeah,
No
I do.
question. Okay, please go ahead.
How would you inherit from, like, let's say more than one contract? Let's say you have contract C, but you want to inherit from A and B, for instance.
Okay. Let's come back here. So we have contract A, contract B. So let's just have something else. Let's say the contract C we talked about. So we could have a contract C here, right? And then we could say contract C is either A, comma B, right? Both of them text. Yep. So you could say contract C is either A, comma B, or you could say B, comma A. This is what I was talking about, the hierarchy of how you do this. If you do this, that means if you do something like, for instance, this is going to complain because of the constructor. Let's just take this guy. And let's go. This is B, so this would be B, not A. And then the linearization of like that have been possible. All right, so I need to go this other way. This is still great. A, all right. So you could do this, right? So you could say A, comma B, and then what this would do is going to first of all inherit the functions, or everything is going to inherit from A first, and then it's going to inherit from B next, right? So I guess why it's complaining is because here I think it's, I don't know, but you have to get from A first and get from B. And let's see the functions: get name, maths. We're using libraries, set name. So we can actually do, well, let's do this instead. We're not going to pass anything into C. I don't know what to pass there. It's just going to be a contract. But if we deploy this, if we deploy C, it's going to look exactly like B, right? Because it's going to inherit everything from A and B, which is basically B is the same thing as A, but this is just for illustration. So C, let's just add something so that let's add something. Let's see. Let me go back. What can we add? We have a name, and then we have a city, and then we can say this is get name and maths. So we can say function. I don't even know what to call this. Anyway, let's call this function. We already have a set city, set name, set city, get name. Okay, let's have a get city here. Get city, and then this function is going to, you have a state variable. Okay, so let's just return this city here. Let's see. Okay, get city public, and then it's going to be a view function because we're reading from the blockchain. And then we want to return a uh, string memory. And then what we can do, there are two ways to do this. We could do something like return super dot, what is it? What's the name again? Super dot city, right? We could do super dot city, and then this should city not found after argument lookup. What's the city name? This is city, right? And this is A, B. Okay, that's not working here. But we can do return city. Return city is a string. Okay. All right. So we can return city there. I was checking out why it was doing that. Sorry, it takes a second. Okay. So if we now deploy our contract C this time around, this is A, B, C. We're still going to pass in the name. Guessing Kenya or guessing Nairobi. So our contract C now is going to have everything from A and B, including C. So we have uh, name, city, function, set name, set city, set name, set city, city name. And what is unique to B is get name and match. So we still have get name, but we have match. So you see that contract C basically has everything that A and B has. So there's no limit as to what you can do, but there's an hierarchy to things. So if A comes before B, certain things, if you call super, is going to refer to A. For now, it's not really important, but when you're writing out like maybe a very complex logic, like I said, inheriting multiple files, the order on which you inherited is very important. Yeah. So, Nelly, I hope that answered your question. Yes.
Yes, thank you.
Awesome. Great. Okay. So, where are we at? Okay, that's that for libraries. This is just an illustration of what I was trying to say. So we have one library, and then, of course, many smart contracts. Multiple smart contracts can use the library depending on the functions they want, but you must always tell your compiler the type that you want to use the library for. If it's a string operation, if it is an integer operation. Yeah. So yeah, moving forward, solidity events. So yeah, earlier I was talking about like events are a way to basically trigger certain locks on the blockchain when certain things happen. This is very important because, of course, if you're writing out most like for front enders, you're writing out, you want to be able to maybe implement notifications for your users. So when certain things happen, you are able to notify your users that, okay, this has happened. So think of events as something or a tool that allows you to do that. Basically, events you can set events for anything. You set events using the event keyword, and basically you can trigger that particular event using the emit keyword anywhere within your smart contract, right? So you could have an event triggered if somebody, for instance, the registration assignment we did. So you would want to have like an event that when somebody registers, probably you want to emit a log that you can always come back to check, or that log can actually be used to trigger notifications or any other thing. So think of events like that, right? So they help smart contracts is a way they help smart contracts to communicate, of course, with the outside world. They do this by logging certain things that happen within the smart contract, right? So, like I said, they are triggered or defined using the event keyword, and then you use the emit keyword to trigger the event. So I have an illustration here of a simple function, this function pay. So once any user calls this function pay, it emits this event, so it emits the user that actually called the function and then the amount the person is sending out. So yeah, so this is one way to use it. Of course, you can also use it for indexing, a lot of other things also. We'll take a look at that in a minute. Yeah, so event and then errors. Yeah, so back to the previous class when we talked about conditionals, where I mentioned that Solidity supports if, else, and all the other conditional statements. Also supports um, logics like or, not, greater than, less than. Supports arithmetics like addition, subtraction, division. So Solidity also it comes with built-in functions that allows us to handle certain errors. You can use these functions by declaring their keyword. For instance, require. Require basically gives a condition that you require. And then an error, the syntax is there's a condition that you require, and then there is an error statement if this condition is not met. Require behind the hood basically is very effective because it's going to, if that condition is not met, it's going to force revert anything that was already done, but it does not return the gas. So if somebody had already triggered a transaction and somewhere along the line the transaction is reverted because the condition was not met, the person will still pay for the gas used for computation up to that stage. But if you use the revert keyword, of course, revert is much more milder, but it's not as forceful as require. So revert, you have to also custom. It allows you to like have a custom logic in terms of what happens. And most times, not most times, when you use revert, the gas that comes with calling that function. If at any point in execution that function is reverted, the gas is, of course, returned back. Of course, we also have the asset keyword, which basically checks for consistency. So you are trying to probably compare two things. You probably want to use the asset keyword. And of course, Solidity allows us to write our own custom errors in case you don't want to use the require and the revert. But then these are very powerful tools. Let's take a look at it before we jump into Foundry one last time. So we have three. We have require, we have revert, we have asset. Okay, let's see how we can plug this in here. So let's say we want to set, also let's talk about modifiers, right? So modifiers are very, very important. So a modifier is a way to basically modify your smart contract in terms of who has or who can call that smart contract. So modifiers in Solidity allows us to have a custom logic that basically determines who can basically do certain things. For instance, call a function or certain things. So this is what I'm using the require statement. So if we had a modifier, say, let's call this modifier, let's say only honor, uh, meaning that what we want to do is that we want any function that we modify with the only honor modifier, we want the address calling this function to be the owner of the smart contract. So what this means is that we need to have the owner as a state variable, right? So can be able to always reference it to see if the address calling it is right. So we can do this, or we can also maybe initialize it in our constructor here, right? The owner is the message.sender, and then we can take this out. So it's one and the same thing, right? So only owner, and here what we want to declare here is we want to use the require statement here. So it will, but the gas is not returned to the end user at the end of the day. But then, like I said, require is very powerful, is very forceful. So depending on the developer, you could use this or you could basically use this. So it's pretty much the same thing. So we have our modifier now. What we can Awesome. So what we can do next is we can use this, say only owner, and let's say we want to set, like for instance, the name, we can include our only owner modifier here. And this would basically uh, So this will basically mean that it's if this condition, right? So once we have our only owner modifier, which we have defined here, right? So if this condition that the message of sender is not the owner, if this condition is not met, of course, the function call would fail. Where is it? Where is it? Where is it? Here. So the function call here would fail. So what this means is if we try to check this out, this is set name. So it doesn't matter, right? So even for the inheriting contract, right? It doesn't matter for the inheriting contract or any contract that inherits from their contract. Anytime you want to call this function, the only person that can call this function is going to be the owner. In this case, remember we define our owner here as anybody, the person that deployed the smart contract. Now this could be anything. It could also mean something like, for instance, for this cohort, we could do something like only students, right? And then we could change our logic for the only students modifier and say maybe require that the message the sender. Probably we want to have an array or maybe a mapping. So I don't want to change this too much. So we could have an array of students or a mapping of students, and then we could have a modifier that checks for all of that. So this is one way to do it. I don't want to go too deep. I want us to look at Foundry. That's why I'm looking at the time. Okay, so let's try to do this and see if that works for us. How this. So now remember we've modified contract A with a modifier, and then I want to deploy contract C just to let's deploy contract C to illustrate this. That it doesn't matter the contract that inherits, the modifier still stands. So contract C is going to be a name. I'm looking for a name. I'm terrible with names. David this time around. And David would be from So we have our smart contracts now, the same as before. But the only difference now is that if we try to call this set name, right, only owner, the owner is, let's see, who is the owner? This is the address of the owner, and then it's this address here. So it's this address. So if we try to call this set name, it should work. Let's set the name from David to, I don't know, Samuel or something. So this should work. And then if we come to get name, we should have Samuel here now, not David, right? But if I should change this address to this address, the second address, and then we try to set the name to Peter or something, this should fail, right? Now this has failed. Let's take a look at it. So this is the last contract call. Let me call this again, just so we see. So it failed, and of course, if we check the logs, it's going to tell us why it failed. Transaction reverted because you are not the owner, right? So you can see that we have modified that function such that a particular address can call it, not all addresses. So that's also I think something worth mentioning, modifiers. Okay. So modifier, but if we should change it back, where is it again? Let's see. If we should change this back, just to prove that you can call any other contract or any other thing. Let's set the city. It's not the address, right? It's still the second address. The second address. We did not modify the set city, right? So let's try to set the city and see if that works. Let's set the city to London from Berlin. It was. So set city works perfectly, and if we get city, we see London, right? So that's that for modifiers and error statement. So basically, you could use a revert statement or a require statement or an assess statement, depending on what you want. And if you don't want to use any of these statements, this require message or sender. If you want to go down to our programming like JavaScript or Python syntax, it's the same thing as your normal if statement. Like I said, you could do something like if say it's the same thing, right? So you could do either an if statement. I don't want to repeat this. I'm trying to get to Foundry. So it's basically the same thing. So you could do that, or you could just use the require statement. The require statement takes a condition first. The condition could be anything, right? Here we are saying the message or sender must be the owner. We could also have something like that. The message or sender must not be the smart contract. So we could have something like message or sender must not equal to uh, address 0. So basically here we are saying we don't want the smart contract to be the one calling this function. So it could be anything. So, but the basic thing is that it takes a condition first, and then it takes a kind of like error message that it will true if the condition is not met. All right. I'm seeing charts. Wow, 38. Can I go through all 38? Let's see. Oh, this is a lot. Okay. Please, if you have a question, please just feel free to unmute and ask a question. Okay, so moving forward, where we are require, revert, asset, and then custom errors. Oh, okay. So right here, we have an assignment which we will do later on, but let's go to Foundry now quickly before I'm seeing another message. Computation will create an opcode. I think that is Vegas is charged. Simon, yes, you are correct. So every computation creates an opcode, and then that opcode has a gas value, right? A fixed gas value. So depending on the combination of your logic, that would translate to many opcodes. So the more the opcodes for a particular function, the more gas your users will pay for that function. So that's what it means. Okay, so I want us to now go to Foundry. So like I said, for JavaScript, sorry, for people like myself that use Windows, you see we have PowerShell here. Even though I have Foundry installed, if I run the forge command in my PowerShell, I'll get an error, right? Because PowerShell wouldn't recognize it. So I have to switch to my gbash. I have other terminals here like Ubuntu, which would also work. But like I said, if you install gbash, which is pretty straightforward to install, you should be fine. So I'm going to switch to my gbash terminal, which would allow me. So here, if I do forge help, I should be good to go, right? So it's going to give me everything about forge, right? So this is forge and all the forge commands you can find. All right, so Foundry, quickly. Check these messages. That's really okay. Uh, let's go. Okay. So let's clear this out for you. All right, so Foundry. Why Foundry? Because Foundry allows us to do everything basically in Solidity. This is what I mean. They will come to files. In the source file, this is, I'm going to show you. This is the source file. Of course, when you spin up the Foundry project, I think sure, oh, I've modified this, but you should have a counter.so file, right? That does a simple count. And then you have your test. So if you see your test file is also written in Solidity, right? So we'll take a look at testing in the next class. In the next class, yeah, that's in 2 days' time. Vulnerabilities and stuff. So this is what I was saying, that Foundry allows us to do certain stuff. Basically, the first standard library basically allows us to do certain things like mimic wallets, kind of simulate different scenarios that could possibly happen on the blockchain. So it allows you to write test cases simulating all these scenarios. And then, of course, if your test case pass, the more you pass your test cases, the more secure the application is. But for today, we won't look at this. We're going to do a simple smart contract, and then we are going to try to deploy that, try to interact with it, and then finally, okay, we'll do everything on Foundry, and then finally, we are going to deploy that on the Leaks testnet. What we would need is the Leaks RPC. So you can find, let me get that link, where is it? You could find the link RPC for testnets. Let me put this in the chats. All right. So this is what we need. This is for, I think this is mainnet. Yeah, this is mainnet. So this is what we need. Leaks Sepolia. And then this RPC endpoint is what we need. So basically from Foundry, when we pass in this RPC endpoints, we are going to be interacting directly with the Leaks blockchain from our Foundry terminal. All right, so we'll take a look at a simple smart contract that basically, from what we've learned so far, so let's try to have a contract inherit another contract, and then basically we try to deploy it and see how it goes. If you have any question at any point, please feel free to call my attention. I'm not seeing the screen, so just feel free to unmute and ask your question. Okay, so I'm going to create, okay, I have one file. So I'm going to create another file that could probably be a library, or let's see. Or I could create a library file and have both contracts in one file. That sounds like it. So I'm going to create, I'm going to create a file in the source directory, and I'm going to call this file lib.so. So for now, we have an empty lib.so. We don't know what we'll put there yet. And then we have our counter.so that will save us where we'll have all our other files. Okay. Any question, guys? That's one. Okay. Oh, there we go. Okay. I'm going to take all of this out, except I'm going to take this out. Where is it? Okay, so we're going to have a contract, and then we're going to call this, what do we call this contract? Let's say simple, yeah, let's see, so C should work. Because I want us to just define certain state variables, and then, of course, inherit these state variables in a new contract, which we would deploy. The AI keeps popping up all these things. I don't know how to turn this down. Okay, so first thing we need is state variable. So our ERC30 token will have a name, a symbol, and these things just keep popping up. Okay, so let's say string name, we have our name and all of this. So I'm gonna take all of this stuff. Okay, I need that. I'm gonna take this out. And then for decimals, probably I'm just going to initialize our decimals here. The parent that wants to transfer has enough of those tokens, right? So I could have something like my require statement here, and I can say I want my condition would be I want whosoever is sending, so the message balance of rather. So we have a balance of marking here. So address returns unsigned integer. That should actually be what to use. So I'm just gonna get this. A lazy typer, guys. Sorry, where was I? So I need the balance of whosoever is sending. So the message to sender. I need that balance to be greater than or equals to the amount that they are sending. In this case, the value. Right, so insufficient balance, thank you here. And then after that, I want to be able to make sure that, okay, the AI is just popping up everything this time. So a simple transfer would take the balance from the previous owner and then it would, so say the balance of the previous owner. We're going to subtract that and then we're going to add that to the value of the new owner. And then once, we're going to subtract from who is sending and then we're going to give it to who is receiving. And then we're going to emit our transfer events that we've sent from this guy to this guy and then we return true. So this is a simple transfer function that basically is going to transfer our token, in this case, the name of the token, and then it's going to do all of that. So we have that simple transfer function. And then we have on this other side, we should be able to mint. So we just need one mint function, and then we should test things out. Looking at the time, it's 3 minutes to 7. So I'm just going to make this quick. Please, if you have any question at any time, feel free to ask. Okay, so on the receiving side, what I can do is we can do rather. What we can do rather is we already initialize our constructor, so we just need a simple function to int. Okay, so the AI is helping me out here again. So so we are minting from address to and then the amount. So this means we are minting from address 0. Okay, I think this is good to go. So basically what this means is that it's going to increase the total supply, it's going to increase the balance of who are minting to, and then it's going to emit the transfer, but this should be mint. We can have the end to say mint, and then the mint will basically take all of this. Yeah, so when we're minting, we know we're minting. When we're transferring, we should know we are transferring. So instead of mint, we want transfer. We want to emit that we are actually minting. So we have two. Okay, so guys, so I've been able to export. I've been able to export our contract. This is the contract address, right? So of course, we want to call the Let's check again. We want to call the balance of, to be sure that the balance of the owner, we want to call it actually 0 first. So we can do that with the cast command. So I'm going to use cast. And then I'm going to call, I want to call our contract through the contract address con. And the contract, the method I want to call is, I want to call the balance of, right? So I'm going to call passing the function, which is balance of. And then this function takes an address. And then, of course, I'm going to pass in the private key. I'm not sure I need that, but it should work without the private key. Length mismatch, output length mismatch, it's crazy. Anyway, balance of address, and then, oh, I didn't pass the address. That's the mismatch. So this is the deployer. So this is the address. So let's gonna get this. So I think we had it as an owner, but let's see. Let's have this address, and then we see the address is 0. The reason we're having this is returning bytes, but it's fine. So what we can do next is we can call send. So now we want to mint. So this function mints. So we're going to mint it takes 2 and the amount, right? So basically we're going to mint, we're going to call past send, and then we're calling our contract. We want to call the mint function, and then the mint function takes, let's see, it takes parameter of an address. So the address, address here, address, and then amount, which is unsigned integer. And then we are going to pass in the address we want to mint to, and then the amount, let's say 1,000. Since we're sending, we need to pass in our private key. So the private key, and then we pass in our private key. So, yep, I think we got that working. We have some transaction and all of that. And then if we should check back the value of the balance of the address, we see, oh, this is giving us bytes. Let's see the actual value. By specifying the data type we want for the return value. So we want to return unsigned integer so that we can actually see it in terms of integer value. So this should give us 1,000, which is what we minted. So you see that we can actually, using the cast, we can use cast to both send transactions here. And then we can also use cast to, of course, interact with the smart contract. So we've been able to basically deploy our my token contract, and then we have the mint function. Remember, it's inheriting from our simple ERC. So basically, we are good to go. So now, last and not the least, we should be able to remember all of this is running locally on our device. This is the last call we did call, right, which was the mint or the balance of, I think. Yeah. So what we can do now is we need to deploy this on an actual blockchain, in this case, the Leaks blockchain. We are going to deploy this on Leaks Sepolia, right? So we need this RPC because it's for Leaks Sepolia. So I'm just going to get this RPC URL. I'm going to copy the link. And then in our Foundry, I'm first going to export this so I don't have to copy and paste it all the time. So this is going to be URL. And then I'm just going to paste the RPC URL. So now we have our contract. We have to deploy this all over again on the testnet, right? So we, first and foremost, I can do a forge clean. to remove existing what has been there already. So basically, I have cleaned my working tree. I've cleared my libraries also. So I can go ahead now to go. I can go ahead to go. That's fine. Anyway, so what we're doing now is we're going to deploy my token, but this time I want to deploy it to the leaks. The leaks network. I need I think I have it stored. Let's see. That's my key. My key should actually see. So we have that. So basically, I'm going to deploy this to the leaks testnet. So we're using Forge, creates, and then we'll pass in my token, which is the token we want to deploy. We want to broadcast this token. No, we want to broadcast the smart contract instead. And then it doesn't take any parameters. So the private key now is going to be private key that actually holds some hits on leaks. So this is going to be my key, I think. And then we're going to pass in the RPC URL. And this is going to be, what did I store it? I think I stored the URL, right? So this should deploy our smart contract on the leaks testnet. Let's see. Okay, so that compiles successfully, and then this deployed successfully on the leaks testnet. To be sure, this is our contract address, right? So I'm going to save this as export. I'm going to call this tests contracts, just so if we go to the Mix Explorer, this is our remix file. So we'll go to our Mix Explorer, which is Sepolia Block Scout. Yep, I'm leaving it. While we wait for that. So basically, we using this command, so we pass in the RPC, pass in our private key, and then we're able to deploy this time not on our local node, but actually on the Leaks mainnet, Leaks testnet, sorry guys. So this is Leaks Sepolia. I'm going to just one more time, I'm going to copy the contract address. And then I'm going to paste it. This is taking a while. Okay. So I'm going to paste our contract address here, and then we should see, so we can see that this is actually a contract, and this contract was created, let's see, okay, this contract was created, let's see when it was created, just so, let's see. So transactions should give us when this contract was created. It takes a while, guys. So while we also wait for that, we are going to try to also interact with this contract. So the first thing we want to do is we want to mint some tokens, right? So this is remember this is live on Leaks now. So I have my address. So I can do send, and I want to send this token, which is our contract address. This contract rather, and then I want to call the mint function, which takes an address and the amount, which is an unsigned integer, right? So we pass in the address. In this case, is my address, and then the how much we're minting, let's say 10,000, just for this. And then we're going to pass in our private key. which is what I stored as my key, if I'm not mistaken. And last and not least, we pass in the RPC URL, which basically tells Foundry that, look, we want to communicate with this particular node on the blockchain, which I stored as URL. So let's see. So we want to mint tokens to my address. So yeah, so basically see how fast list is. List is 2 seconds. So basically this is from me, and then I was able to interact, and this is the log, this is some transaction hash. So if I should call to check my balance, let's see, I'm going to try to check my balance by saying cast send, and then I'm going to send the contract actually is what's the contract? Well, I think I have forgotten the contract. I need to see. Yes, one minute. I don't know. The environment I save it as. Okay, so let's see. Ads okay, exist total contract. I think that's what I saved it as. This should exist. Token contract. Okay, I'll find it. But all right, so I can also get this. This is my contract address, right? So that's the good thing. I can copy this. Now you can see 5 minutes ago, we created the contract. We minted some seconds ago. And then I want to see the balance. So I'm going to see cast call, call my contract. And then I want you to call the balance of function, the balance of this address. And I want to return some integer type so that I can actually see the real value. And then I'll send the RPC URL. RPC URL, this URL. I didn't pass in the address that I want. So my address is, to get my address again. So this is my address. So I can pass in my address here. And there we go. This should work. So you can actually see that I have minted 10,000 NFT, sorry, 10,000 tokens, not NFTs, right? So that's pretty much it, how to use Foundry to interact with the smart contracts. You can basically use your command line to interact with this, or you could use scripts to actually write it. Of course, we have your assignments, which basically you should be able to utilize what we've learned today in terms of the conditionals, in terms of using Foundry. If you're not comfortable with Foundry, you could still use Remix. It's still good to go. But basically, with Foundry, you should be able to do big boy stuff, right? All right, so that's pretty much it. The assignment has been released in the classroom. If you have any questions, we would always continue in the group chat. Thank you guys. Ciao.